Question: voltage and current in a circuit with 50 Hz supply are represented as follows. V is equal to 282 sin omega t and I is equal to 14.1 sin omega t minus pi by 6. Draw the two waves to scale on the same time axis and find out number 1 RMS value of current, number 2 average value of voltage, and number 3 power consumed in the circuit. Solution: first of all we will write what is given. So V is given, instantaneous voltage 282 sin omega t. Current is given, I is equal to 14.1 sin omega t minus pi by 6. The value of frequency is given, f is equal to 50 Hz. So we have to draw these waves on the graph. So we know that frequency f is equal to 1 upon t. So therefore t is equal to 1 upon f. So 1 upon 50. 1 divided by 50, it will be 0.02 or 20 millisecond. So 20 into 10 to the power minus 3 second or 20 millisecond. Now we got the time period. The frequency for both voltage and current will remain same. Now here is the graph. So let's take this as a reference. Let's say this is the peak value. This is time in second, in millisecond. So the waveform will look like this. Now let's say this is the waveform for, this is V or I, that is voltage or current, and this is time. We have to draw the waveform for both voltage and current. So for voltage, if we compare this with standard expression, V is equal to Vm sin omega t. So Vm value is 282. So here this will be 282 volt. Vm is equal to 282 volt. Then its time period will be of 20 millisecond. So let's say this is 10 millisecond and here this will be 20 millisecond. So this is total time period t. This is the waveform for voltage. We can write V is equal to 282 sin omega t. Then next we have to draw for current. So for current, it will be again I is equal to Im sin omega t. So here also the maximum Im value is 14.1. And here the phase angle is also given, it is minus pi by 6. So let's say this is 0, this is pi, this is 2 pi. We will take different color. This is 0, this is pi, this is 2 pi. Now if we take the half of this pi, so here this will be pi by 2. And again if we take half of this pi by 2, so it will be (0.5) divided by 2. So it is 1 by 4, that is pi by 4. This will be pi by 4, and again this is pi by 4. Again if we take half of this pi by 4, so pi 0.1 by 4 divided by 0.25 divided by 2. So it will be pi by 8. So pi by 8 will be somewhere here. So pi by 6 will be somewhere here. So the waveform will look like this. This is the waveform for current. So I is equal to 14.1 sin omega t minus pi by 6. Now this pi by 6 represent, minus sign represents that it is lagging. So here it will be like this. This is the waveform for current. Then next is we have to find the value of RMS value of current. So let's find the RMS value of current. And also remember that the maximum value for this will be 14.1. So here it will be 14.1 ampere. This is the value for Im. Then RMS value of current, that is IRMS we have to find. So IRMS is equal to Im divided by root 2. So the value of Im, here we know that the value of Im is 14.1. 14.1 divided by root 2. (14.1 divided by root 2), 9.97 ampere is the value of IRMS. Then next we have to find average value. So for average value, I AVG is equal to pi by 2 into Im. Not pi by 2, 2 by pi. 2 by pi into Im, because 2 divided by pi is 0.636. So 2 by pi into Im. Again, Im value is 14.1 into 14.1. So it is 8.97 ampere. Then next, power consumed in the circuit. Next we have to find power consumed in the circuit. We know that power is equal to Vrms into Irms into cos phi. So here the value of voltage, the value of Vrms is, we know the value of Vm here. So in place of Vrms we can write Vm divided by √2, and we know the value of Irms. So into Irms value is 9.97 into cos the value of phi. So here the phase angle phi is pi by 6, because it is Im sin omega t plus phi. This is the correct expression, Im sin omega t plus phi. So phi is pi by 6. That will be minus pi by 6 to be more precise. Then again Vm value, the value of Vm is 282. 282 divided by √2 into 9.97 into cos into minus pi by 6. So let's solve this. 282 divided by √2 multiplied with 9.97 into cos minus pi by 6, or we can take minus 180 divided by 6. So it is 1721. 1721.20. 1721.70. And since it is power, so its unit will be watt. So this is how we can find RMS value, average value and power consumed. And this is how we draw the waveforms. I did the little mistake here. We have to find average value of voltage, but I found the average value of current. So let's change this to average value of current. Now let's find average value of voltage. Again, let's copy from here. Let's paste it here and let's number this as number 4. Now to find average value of voltage, V AVG is equal to Vm divided by V average is equal to 2 by pi into Vm. So 2 by pi multiplied with Vm value is, the value of Vm is 282. So 282. So 2 divided by pi into 282. So it is 179.52. Since it is a voltage, so its unit will be volts. So this is the value of average voltage, power consumed, average value of current, RMS value of current. And this is how we can draw the waveform.